Can you pass the AP Anti-Brain Rot quiz by answering just 3 of these easy chemistry questions? Let's find out. What state of matter has a definite shape and volume? Solid. In which state of matter do particles flow freely and take the shape of their container? Liquid. What term describes the random motion of gas particles? Diffusion. What instrument measures gas pressure? Barometer. Which state of matter has neither a definite shape nor a definite volume? Gas. Comment down how many you got right and follow me for more.
What's good, everybody? Back at it again with Skibidi Science. In today's video, we're going to discuss the physical states of matter, gas pressure, and its measurements. I'm going to hand it off to my Sigma boy over here so he can do the talking and delving into the material. Let's get it.
Hello friends, I am the Sigma boy in question. Before we dive into gas pressure, let's quickly review the 3 main physical states of matter. We have solids, where particles are closely packed and have a fixed position. Liquids, where particles are close together but can move freely. And gases, where particles are widely spaced and can move freely. We can imagine a container. The gas would adopt the shape of the container and fill it. The liquid adopts the shape of the container, but to the extent of its volume, and a solid would stay the way it is regardless of the shape of the container. I encountered all 3 states of matter on my expedition to meet you here.
Thanks for the quick review, Sigma boy. Now let's talk about gas pressure. Gas pressure is the force exerted by the molecules of a gas on the walls of its container. This force is a result of the constant movement and collisions between gas molecules. The more molecules in a given space, the greater the pressure. There are 5 things to take note of regarding the behavior of gases. Gas volume changes significantly with pressure. Simply, when gas is compressed, its tendency to spread apart would increase as it is more compressed, which means more work is done. Take an example of tires. The gas inside the tires are compressed in a way that it would lift the cars up. Secondly, gas volume also changes significantly with temperature. As we all know, particles vibrate and move more as temperature increases, thus the volume will expand. Third, gases flow very freely. Particles in gases are more spread out and have more space to move and flow freely. This allows them to be transported easily through pipes and also leaks more rapidly. Gases also have low densities because the particles are more spread out. Lastly, gases from a solution in any proportions, just like in homogeneous liquids, the composition is not distinguishable, but will be in a certain proportion. However, in gas, no matter the proportion of gases mixed up, it would not be distinguishable. Alright, enough yapping. I'm gonna hand over the mic to my boy Mark.
Hey there! Over here at Meta, we love to talk about all types of science, including chemistry. So, how do we measure gas pressure? Generally, gas pressure is defined by the formula force over area. There are several ways to do this. One common method is using a pressure gauge, which is a device that measures the pressure of a gas. There are different types of pressure gauges, including analog and digital gauges, as well as gauges that measure pressure in different units, such as pounds per square inch, psi, or millimeters of mercury, mmHg. Scientists used barometers and manometers to measure gas pressure. The barometer is used to measure atmospheric pressure. The device is still essentially the same as it was when invented in 1643 by an Italian physicist called Evangelista Torricelli. It uses a column of mercury or another liquid in a sealed tube. The height of the liquid column changes in response to variations in atmospheric pressure. Higher pressure pushes the liquid up, while lower pressure allows it to drop. This change in height is read against a calibrated scale, indicating the current air pressure. The other device is called the manometer, which are devices used to measure the pressure of a gas in an experiment. This includes the open-end and closed-end manometer. An open-end manometer measures the pressure difference between 2 points in a system using a U-shaped tube partially filled with a liquid, typically mercury or water. One end of the tube is open to the atmosphere, while the other end is connected to the system being measured. The difference in height between the liquid levels in the 2 arms of the U-shaped tube indicates the pressure difference between the system and the atmosphere. A closed-end manometer measures the pressure difference between 2 points in a system using a U-shaped tube partially filled with a liquid, typically mercury or water. The liquid levels in the two arms of the U-shaped tube adjust until they balance, with the difference in height between the two columns indicating the pressure difference between the 2 points. By measuring the height differential between the liquid levels and accounting for the density of the liquid, the pressure difference can be determined. When measuring gas pressure, the units involved include several, such as the SI unit Pascal, P, standard atmospheric pressure, ATM, or millimeter of mercury, mmHg. Such units have the conversion of such.
Thanks for the explanation, Mark. So gas pressure has many practical applications in our daily lives. For example, it's used in scuba diving to control the air pressure in scuba tanks, and in medical equipment to deliver precise amounts of oxygen or other gases to patients. It's also used in industrial processes such as manufacturing and power generation. That's it for today's video on the physical states of matter and gas pressure. We hope you learned something new and interesting. Remember, understanding the behavior of gases is crucial in many areas of science and technology. Thanks for watching, and we'll see you in the next video.